Here we're going to be dealing with the function f of x equals 2x plus 3 over x plus 1. We're asked to first evaluate f of 100, f of 1,000, and f of 10,000 to 4 decimal places. So really we're just saying, like, as the x increases, what's going to happen to the function, or what's going to happen to the y value. So to do that, I would just plug in 100 in for x, 100 plus 1. Then I would plug in 1,000 plus 3 over 1,000 plus 1. Then I'd plug in 10,000, 1, 2, 3. And I would just do this on a calculator. And what I end up getting is I get 2.0099 for the first one, then 2.00099, which actually rounds to 2.0010. And then last one, 2.0001, if I round that correctly. So the pattern that we're looking for here is that we notice that this number here is getting smaller, but it's not going down forever. It's really getting closer and closer to the value of 2, which helps us answer the second question here. What's the horizontal asymptote? Well, if as we get closer and closer to infinity in the x value, and we're getting closer to 2 in the y value, that's what we consider a horizontal asymptote. So our horizontal asymptote is at y equals 2. For C, it says, does y equals f of x have a vertical asymptote? If so, what is its equation? So we're looking for the vertical asymptote, which is nice and straightforward because I can just look at what makes the denominator 0. And so my vertical asymptote is going to be at x equals -1, because I know that vertical asymptotes talk about the x values, and the only x value that's not allowed is what makes the denominator 0. For the last one, it says rewrite f of x as a stretch and shift of 1 over x. And to do that, if you have done the classwork, you are just going to be doing division. So we're going to divide here. I'm saying, what do I need to multiply by x plus 1 to get to 2x plus 3? I know this has to be 2 to multiply into 2x. 2 times 1 is 2. These two have to add to 3, so my remainder here is going to be 1. So I got 1 over x plus 1 is my remainder, and so 2 plus 1 over x plus 1 is what I get when I divide, but if I'm looking to make it look similar to what we've dealt with for shifting our original function, I'm moving this 2 to the other side so I can see that that is where I get my horizontal asymptote from. And so here is my transformation form of the original equation we were given.